Good morning, good afternoon, good evening, depending on where you are getting us from. Welcome to today's Solar Power Engineering Lecture 4, where we'll discuss solar PV energy production estimation. So how do you estimate the amount of energy that you are able to produce from a solar PV? So earlier on, we have built on knowledge where we talked about the irradiation as the energy source from the sun that is responsible for production. We also reviewed certain concepts to do with the albedo for surfaces, that is cloud, sand, and snow. We also looked at the direct, normal, direct horizontal, and global horizontal irradiations, which are the GNI, THI, and GHI. We also introduced the solar constant, which is a value of 1,367 watt per meter square, which is received at the top of the Earth's atmosphere. So the energy is actually transferred to the Earth's surfaces daily, weekly, monthly, or yearly. There is this production. If we also go to basic principles, we also see that we've got energy is equals to power times time. And also to calculate the energy under a graph, we actually apply calculus by estimating the area under the curve. So when we move on, we have got a daily solar production from the northern hemisphere. So this is typical of what you expect from a certain place if you have an installed capacity. So if we look at every hour within a day, we actually have got a cycle of production that looks like that. So demarcating per hour, we see that each hour has got the time aspect and also has got the peak aspect until we reach the maximum of the installed capacity. So if we look at the shapes and the area under the graph, we can actually estimate this using calculus given by that formula, where energy is the integral of the power against time for the time between T1 and T2. So T1 is when we start production just at 0.5 and end just at 19. This is how much energy is contained in our graph. But again, we can illustrate a general formula. If we look at these shapes gives us a trapezium, which is half times A plus B times the height. So in this case, our A and B are the power at each time and also the time interval, which of course it's 1 hour, 1 hour. And also if we go to specific, we actually start from 0.5, 0.6, and we have got that until we actually have all the time. So we can actually estimate this, but this is more accurate, more actual, time evolving. So we move on to look at the energy approximation over a production cycle. If we don't consider a trapezium, what can we consider next? So we can actually extract a triangle from our graph, starting from somewhere before 6 and also ending somewhere after 6. So we have got this triangle, which we can actually remove from our graph to say we now have got the height, which represent our installed capacity. And then we also have got the base, which is the hours of daily irradiation. So the area of the triangle gives us the quick design parameters that we can actually use to estimate the energy that the system is able to give us. The height gives us the peak or maximum value of the solar that we have installed. The base gives us the hours of irradiation within that day. So it has got to be done for every day. So we can actually even have an average over a year to actually approximate how much we can actually produce with this system. So if we go in terms of formulas, we actually have got the general formula in relation with the triangle, which gives us half base times the height. Then in terms of specific, we have got the time from when production starts, PS, to the time when production ends, PE. So half times TPS to PE times PV peak or the maximum. So having established this concept, we will now move on to look at numerical calculations where we apply this to a design problem. And then also, if we look at all these hours, we've moved from a trapezium, which is a bit complex level. We move to a triangle, then we can actually move to a rectangle, which is just multiplying of two values, time and also our peak value or the maximum value of solar PV. So that time, if we have to have a triangle, we must actually equate our graph to have time, which is called the equivalent or the peak sun hours, ESH and PSH. So in the next lecture, we'll actually look at the numerical calculations, application to design problem, and also the ESH and PSH to move on to another stage in building up the knowledge. Thank you very much for watching. This is where lecture 4 ends. Remember to subscribe, like, and share, because we are going to build knowledge that will give you enough base when you are going to design your system. If you have got questions, you can send them to my email. It doesn't matter whether you are from India, you are from Zambia, you are from a country in Africa, you are from any other countries around the world. Send me your questions. Then we'll be able to explore more of what we have in terms of knowledge in solar power engineering. Until next time, it's bye for now.